Good morning, students. Last time you have learned the uh, critical phenomenon, okay, and continuity of the state and exceptional behavior of the hydrogen and helium gas, okay. And in case of hydrogen and helium, their PV values are greater than the PV values of ideal gas, because the hydrogen and helium, they are lightest one, and both the corrections, that means pressure correction and volume correction, it is negligible. So according to the van der Waals equation, we obtained the equation for PV, and PV it is equal to RT plus PB. It indicates that the PV values are greater, and in case of Joule-Thomson effect, instead of cooling, hydrogen and helium, they get warm. This is the exceptional behavior of hydrogen and helium. Let us begin with the relationship between van der Waals constant and critical constant, or it is also called as the derivation of critical constants from van der Waals constant, and we derive the relationship depending on the van der Waals equation. It holds good at the critical temperature. Okay, so at first all of you know the van der Waals equation for n moles. Here P plus A into n square by V square into V minus NB, it is equal to nRT. We have derived this van der Waals equation. This is the van der Waals equation for n moles. Then for 1 mole of gas, the van der Waals equation we can write here P plus A upon V square in bracket V minus B, it is equal to RT. Let it is our expression number this. Okay, then from the equation we can derive the values of critical constants. That means critical pressure we denote as Pc, critical volume we denote as a Vc, and critical temperature we denote as a Tc in terms of A and B, the van der Waals constant, on expanding this equation. So the expansion of this equation, here we have PV plus AV minus PB minus AB upon V square minus RT, it is equal to 0. Okay, and let it is our expression number 6.24. Here we have simply expanded this equation and we obtain this equation. Then multiplying this equation by V square and dividing by P, we get V square by P in a bracket PV plus A by V minus PB minus AB upon V square minus RT, it is equal to 0. Okay, by multiplying V square and dividing P, we get this equation. So the expansion of this equation, we get V cube plus AV by P plus minus B into V square minus AB by P minus RT V square by P, it is equal to 0. When the above equation is rearranged in the cubic power of V, we can write this equation as V cube minus RT by P plus B into V square plus A by P into V minus AB by P, it is equal to 0. Okay, this is the cubic equation, and this equation indicates that The volume, it has three values, and amongst these three values, one may be real and positive and other two are imaginary. This equation 6.26 is cubic equation in phi. On solving this equation, we will get three solutions at the critical point. All these three solutions of phi are equal to the critical volume Vc. The pressure and temperature becomes Tc and Pc respectively. According to Thompson Effect, here he plotted the theoretical isotherms for CO2 gas. Okay, and depending on this equation, cubic equation in phi, we can have a three values of phi also. Okay, so under this we can write phi, it is equal to Vc, and phi minus Vc, it is equal to 0. Therefore, the phi minus Vc bracket cube, it is equal to 0. And expansion of this equation, we have phi cube minus 3 phi c into phi c square plus 3 phi c square into phi minus phi c cube, it is equal to 0. This is our suppose equation number 6.27. As equation 6.26, this equation is identical with this equation 6.27. We can equate the coefficients of phi square, phi and constant term in equation 6.26 and 6.27. Here, this is the coefficient of this term phi square. Therefore, here we have minus 3 phi c phi square. It is equal to minus RTC by PC plus B into phi square. Okay. Therefore, 3 phi c, it is equal to RTC by PC plus B. It is our equation number, suppose 6.28. Then 3 phi c square, it is equal to A by Pc. Then phi c cube, it is equal to AB upon Pc. This is our expression number 6.30. Then dividing equation number 6.30 by equation number 6.29. That means this equation divided by this equation, and we get Vc cube upon 3 Vc square, it is equal to AB by Pc divided by A by Pc, and we can cancel the numerator and denominator same values here, and we get Vc by 3, it is equal to B. Therefore, from this equation we have Vc equal to 3B. That means the critical volume, that is Vc, it is equal to 3B. Okay, Vc equal to 3B. We have obtained the value of Vc. Then when equation number 6.31 is substituted in equation number 6.29, here this is our equation. Okay, so 3 Vc square, it is equal to A by Vc, and therefore Vc, it is equal to A by 3 Vc square, it is equal to A upon 3 in a bracket 3b square, and it is equal to A upon 3 into 9b square, and it is equal to A upon 27b square. And from this equation we can have the value of Pc, and this value of Pc, it is equal to A upon 27b square. Okay, this value of BC it is equal to A upon 27b square, and let it is our expression number 6.32. Then the substituting the values of VC and PC in equation number 6.28, we get here we have 3 VC it is equal to B plus RTC by P, and we have the value of VC as a 3B. Therefore, here we can write 3 in a bracket 3B. It is equal to B plus RTC, and substituting the value of PC here A by 27 B square, and solving this we get 9B minus B it is equal to RTC by A into 27 B square. Therefore, we get 8B it is equal to TCR into 27B square upon A. Therefore, here we can write the equation for TC as TC it is equal to 8AB upon 27RB square, and here we have BB common. Therefore, we can cancel one B from here. Therefore, the simplified equation for TC it is equal to 8A upon 27RB. Here 8A upon 27 RB. This is the value of TC, and let it is our expression number 6.23. The critical constants can be calculated using values of van der Waals constant of the gas and vice versa. And we can have A it is equal to 3 VC square into PC, and B it is equal to VC by 3. These are the critical constants in terms of critical constants. And next time we will derive the equations for van der Waals constant in terms of critical temperature and critical pressure. Okay, so once again we revise the relationship between van der Waals constant. All of you know the van der Waals equation for n moles. We have P plus A into n square upon V square into V minus nB it is equal to nRT. Okay, and for 1 mole we have P plus A upon V square into V minus B it is equal to RT. From the equation we can derive the values of critical constants. Okay, and that values are PC, that means critical pressure, VC means critical volume, TC means critical temperature in terms of van der Waals constant as A and B. Then on expanding the above equation, this equation, we can have the product of these two brackets. We get here PV plus A by V minus PB minus AB upon V square minus RT it is equal to 0. Multiplying this equation number 6.24 by V square and dividing by P, we get V square by P in a bracket PV plus A by V minus PB minus AB by V square minus RT it is equal to 0, and this V into V square it becomes V cube. So we have V cube plus this PP get cancelled. Okay, A into V by P minus here B into P square minus AB upon P minus RT P square upon P. It is equal to 0. Then, when the above equation is rearranged in powers of phi, we can rearrange this equation in powers of phi. We can write here phi cube minus RT by P plus B into phi square plus A by P into phi minus AB by P, it is equal to 0. And this equation is the cubic equation in phi. On solving this equation, we will get three solutions. At the critical point, all these three solutions of phi are equal to critical value. Okay, the pressure and temperature becomes Pc and Tc respectively. Therefore, we can write phi it is equal to Pc and phi minus Pc it is equal to 0. Therefore, phi minus Pc bracket cube it is equal to 0. The cubic expansion, this is the cubic expansion of this equation phi minus Vc bracket cube. And here we can write phi c phi cube minus 3 phi c phi square plus 3 phi c square into phi minus phi c cube it is equal to 0, as this equation identical with the equation number 6.27. We can equate the coefficients of phi square and phi and the constant term in equation number 6.26 and 6.27. So we can write minus 3 phi c into phi square it is equal to minus RTC by PC plus B into phi square. And simplifying this equation here, 3 phi c it is equal to RTC by PC plus B. Therefore, 3 phi c square it is equal to A by PC and phi c cube it is equal to AB by PC. This is the equating the coefficients of equation number 6.26 and 6.27. We get these three equations. Then dividing equation number 6.30 by equation number 6.29, we get Vc cube by 3 Vc square it is equal to AB by Pc upon A by Pc. Therefore, Pc by 3 it is equal to B, and from this equation we have Pc equal to 3B. Okay, Pc equal to 3B. When equation number 6.31 is substituted in equation number 6.29, we can write 3 Pc square it is equal to A by Pc. Therefore, Pc it is equal to A by 3 Pc square it is equal to, putting the value of Pc as a 3B here, A upon 3 in a bracket 3B square it is equal to A upon 3 into 9B square, that means 3 square that means 9, and it is equal to A upon 27B square. That means we have here the value of Pc. Here Pc it is equal to A upon 27B square. Then the substituting values of Pc and Pc in equation number 6.28, we get 3Pc, it is equal to B plus RTC by P. Okay, substituting the values of Pc and Pc in equation number 6.28, we can write 3Pc, it is equal to B plus RTC by P. The value of Pc, it is 3P. So we have put here value of Pc, it is equal to B plus RTC, and the value of Pc, it is the A upon 27 B square, and solving this we will get here 3 into 3 9, and we put this B from right hand to left hand, we get 9B minus B, that means 8B. It is equal to here RTC by A into 27B square. This is our numerator, and here divided by A as it is. Therefore, from this equation we can write the equation for TC as TC, it is equal to 8AB upon 27 RB square, and we have in the numerator and denominator common term B. Therefore, we cancel one B from here and we get 8A upon 27 RB. Therefore, we have the value of TC as 8A upon 27 RB. So, here we have obtained the values of PC, VC and TC. And in terms of VC, that means critical volume and critical pressure, we have the value of A as A, it is equal to 3 VC square into PC, and B, it is equal to VC by 3. But we can also calculate the values of A and B in terms of critical constants, that means in terms of critical pressure and critical volume also. Here remember the value of TC, it is equal to 8A upon 27 RB. The value of PC, it is equal to A upon 27 B square, and the value of PC, it is equal to 3B. Okay, so the problems depending on the values of PC, VC and TC we will see next time. Thank you, and go to the YouTube channel and watch the videos there, and subscribe also the channel so that you will understand well. Thank you.